Hello everyone, welcome to the next video of C program. Relationship between array and pointer. We have done the separate video for array as well as for pointer. So before watching this particular video, I'll suggest everyone must go through the video of pointer as well as array so that you will find the relationship between array and pointer. Okay. So before going to the video, let us see one example. We will declare one array first and we will assign the value. Okay. So 5 values are present in my array. So if I'll print, so what I'll get? So for array of 0, definitely I'll get the first value. Let us see. Yes, we got 11. Okay. Now next thing I want to print. So what I'll get here? I'll get the address of the first element. That means if we are declaring a particular array, it has 5 blocks with index ranging from 0 to 4, then this particular address of the array index 0 will get as output. Okay. So let us see. We are getting some value 6487600. We don't know what is that. Okay. But we are sure that this is the address of the first element. Now the next thing I want to print here, the array name. What will happen if I'll print the array name? Now here is the beauty that again we are getting the same value whatever you have got whenever you have printed the address of the first element. So that means whenever I am printing the array name, that is also printing the starting address. So that means array name holds the starting address of the array. Okay. So array name is holding the address means array name is nothing but it's a pointer. That means it keeps the address of the first element. Okay. Now let us rewrite the same sentence. I'll add 0 with error. Now what will happen? I am writing error. I am writing error plus 0. Both are same or not? Let's check. Yes, we are getting the same output. Obviously, something is added with 0 means it will give you the same value. Okay. Now the same thing I am writing once again where I am adding 0 first. As addition is commutative, so I am expecting the same result again. Yes, we are getting the same result. Okay. Now, can I write like this? If I write star of error plus 0. Okay. What is error plus 0? Error plus 0 is the starting address. Star means value at that address. So what is the value at 0th index? Now that is 11. So I'm expecting 11 here. Okay. So that means we have understood one thing here, that if I'm writing array of 0 and I'm writing ARR plus 0 star, both are same. Okay. Now ARR plus 0, I can write 0 plus ARR. So array of 0 also, the same thing I am getting. Okay. So can I write 0 of ARR? Okay. I am writing ARR of 0 as ARR plus star, ARR plus 0 star. Okay. Again, I can write the same sentence with star here also. Okay. ARR plus 0 star and 0 plus ARR star. Both I am expecting the same result. Yes, 11 and 11. So that means my question is here that ARR of 0 can be written ARR plus 0 star. So 0 plus ARR star, can I write like this? Okay. Can I write like this? That means I am expecting 4 11s here. Let us check. Yes, we are getting 4 11s. Okay. This 11 is here the above. Okay. So that means here is the beauty of my array and pointer. That means I can write ARR of 0 same as ARR plus 0 star, same as 0 plus ARR star, same as 0 of ARR. Okay. So if I'll replace 0 with 1, so can I get the second value? This is my question right now. I have just replaced 0 with 1 and I'm expecting whatever array of 1 I'll give, ARR plus 1 will also star will give the same value and the rest of the 2. That means I'm expecting 422s as my output. Yes. Okay. How it is happening. Okay. So there is a simple thing here. Now whenever I'm writing array of 2, it's like ARR plus 2 into size of the data type. Okay. And then the whole star. ARR means the starting address. Okay. Let the address is 1000 plus 2 into what is the data type of integer? This is your 4 complete star. So this will be star of 1008. Okay. So if we'll draw the diagram by ourselves, 0, 1, 2, 3, 4, 11, 22, 33, 44, and 55. And if the starting address is 1000, because in ARR we have written 1000. So this will be 1004, this will be 1008, 1012, and 1016. So if I write star of 1008, so value at 1008 is 33. That is what my array of 2. Okay. So any array index you are calculating, this is what the formula, that the base address or the starting address plus which index value you are calculating into the size of the data type total star. So that you will get the value. So whatever you are writing, whether you are writing array of 1, you are writing ARR plus 1 star, 1 plus ARR star, or 1 of ARR, all 4 will be considered as same. Okay. Because internally the calculation is something different as per the formula. Okay. Now if I'm writing for 1, I can write for 2, I can write for 3, I can write for 4, I can write for 5. Okay. So let us remove everything and write down the original example. Okay. So I'll use a for loop, I equal to 0, I less than 5, I plus plus. Okay. And I'll write down these 4 statements inside. Okay. What I'll write here? I'll write I. Instead of 1, 2, 3, whatever, I'll write on I here. Okay. So I need to print the output in a single line. So /t. Okay. So let us execute. So what will happen? First array of 0 will be, the value will be printed 4 times. Then 22 will be printed 4 times. Like that for all values. Done. So all 4 are giving the same output. Done. Now we'll modify the same code again. What we will modify? Now we know that there can be a pointer variable which will keep the address of another variable. We have seen that the array value or the array name itself stores the address. So that's why this is again a pointer variable. But if you want, you can choose another different pointer variable for array. Then what I'll write down? Ptr equal to, either I'll write down address of array of 0, or what I can write? I can write only the array name. That's all. Okay. So that means wherever I can write the array name, I can write down the pointer name. So these 4 statements I can write down like this. Wherever I can write ARR, I can write PTR, because PTR and ARR both are same. So this is what our conclusion in this particular video, कि the pointer and array both are same because array name holds the starting address. So that means I am expecting the same result 8 different times. 4 times, 4 times, 8 times. So every value is printing. So what you have understood here, now whatever the array name you are writing array of A of I, you have to write ARR plus I star. That means any array program you are writing like this, a array of index, it is giving you value. The same thing I can write star of ARR plus index. Same thing, if you are taking another extra pointer variable, I can write star of PTR plus index. So if you are acquainted or familiar with this particular concept of accessing array value, you can easily convert by using pointer, so that the array name plus the index, the whole star. Okay. So by keeping all these things in your mind, let us write a simple program. Okay. So one program we have already written, that linear search program in array. Okay. How we have written, that is already present in the programs video of one dimensional array. Okay. We will rewrite the same program by using pointer. Okay. So first of all, what we will do, let us write down by using the same array name. Okay. So wherever I have written address of array of index, I have to write array plus index. Okay. Address of array of index, we can write ARR plus index. Wherever I am writing array of index, the value, what I'll write? A star of ARR plus index. Okay. I am not changing anything. I am just changing the format only. Wherever I need value, I'll write down star ARR plus index. Okay. So let us execute. So how many values? So 5, 11, 22, 44, 66, 77. You want to search 44. The value is present. Because why I am not going in details, this program already you have understood whenever the video you have prepared for programs by using 1D array. Okay. So there we have written the entire program by using array. In this program, we have converted the array program by using pointer. So wherever ampersand is required, you are just adding the index. Wherever you are accessing the value, you are writing star of that one. Okay. So let us understand one more program. Sum of elements of an array. Okay. So what we have told, Wherever I am writing address of something, you will only write ARR plus index. Okay, no need of ampersand. Wherever I am writing value, I need to write star ARR plus index. I need value here. So what I'll write? Star ARR plus index. Okay, this is the only difference between your array and pointer. So 5 values I want to access. This is what the sum. Okay. So any array program that you know how to write, you can easily convert by using pointer. Okay. Now suppose the same program, you want to take another extra pointer variable. So I'll declare one more extra pointer variable. I'll write ptr equal to ARR. Now the address is being assigned. So wherever you have written ARR, you write ptr, because ptr and ARR both are same. So wherever you need to write ARR, you have to just replace with ptr. Just check it out. 4 values. This is the result. Okay. So that means what is my objective here? If you are comfortable with array program, then definitely you can convert to pointer program, because the array name itself holds the base address or starting address of an array. Okay. So these are some examples we have done in this video. So what is my suggestion here? You write some more programs by using array only, then convert the same program by using function, and convert the same program by using pointer. Okay, and you will see there is no difference between your array and pointer, because the array itself is a pointer only. Okay, so thank you everyone for watching this video.